Hi, and welcome to Intro to Trig Day 1. Some of this information you do already know. It's a little bit of a review plus some new things. Okay, some of you are familiar with Soh Cah Toa. Okay, and Soh Cah Toa is sine is equal to the opposite side over the hypotenuse sine. Excuse me, let's try that again. Sine is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. And your opposite and adjacent change depending on which angle you're talking about. So for example here we have a 5, 12, 13 right triangle. And the sine of A, when we're looking at angle A, sine is opposite, which is 5, over the hypotenuse, which is 13. The cosine would be the adjacent, which is next to, over the hypotenuse, so it would be 12 over 13. And then the tangent is opposite over adjacent, so it is 5 over 12. Now if I go over to angle N, which is up here on the top, and I do the sine, I'm going to do opposite over the hypotenuse here. So it would be 12 over 13. For the cosine of n, the adjacent is 5, and the hypotenuse is 13. And then for the tangent of n, it would be opposite, which is 12, over adjacent, which is 5. The only side that's fixed is the hypotenuse, because that's always across from the right angle. We have what we call a 30, 60, 90 right triangle. And the sides are in the ratio of x to x radical 3 to 2x. So it's 1 to radical 3 to 2. And in that 30, 60, 90 triangle, this is the 30, this is the 60. And what it's saying is, when you look at the relationship, the hypotenuse is twice that of the side across from the 30, and the side across from the 60 is whatever is across from the 30 times radical 3. So for example here, my first triangle, I have 1. This is my right angle. This is my smallest side. My smallest side is across my smallest angle, so that's across from the 30. So my hypotenuse is twice the 1, and that is 2. And then across from the 60 would just be 1 radical 3, or radical 3. On my next triangle, I have the side across from the 60, which is 2 radical 3. So that means my shortest side across from the 30 is 2. My hypotenuse has to be twice that, so it is 4. For the next one, I flipped the triangle over, but my hypotenuse is 10, so my shortest side has to be 5, and the other side has to be 5 radical 3. Again, my triangle is flipped. I have the side across from the 30, so that means my shortest side is 3, and my hypotenuse has to be twice that, which is 6. And on the last one here, my hypotenuse is 100, so half of my hypotenuse is 50, which means the other side is 50 radical 3. All right. So in the next one, triangle MAT is equilateral, and equilateral means that all sides are congruent. AH is an altitude. Well, I'm going to have to draw AH in. So my altitude forms a right angle. MA is equal to 8. Well, if this is an equilateral triangle, then we know that AT is equal to 8 as well. So we can go ahead and label that. The measure of angle M is an equilateral triangle. All my triangles have the same angle measurement, and they are 60. So that means that M is 60 and T is 60. And MHA is a right angle, so that's 90. And THA is also 90. It's a right angle. MAH, well, if this is 60 and this is 90, in triangle MHA, I only have 30 degrees left. And TAH, it's the same idea, so that is 30. We knew that AT was 8. MH, well, if you look at this, I have a 30, 60, 90 triangle over here. And what we just did in example 2, if I have the hypotenuse, which is 8, the side across, so the shorter side across from the 30-degree angle has to be half the hypotenuse. So that makes that 4. And that's going to happen with the other triangle as well. And then AH would have to be across, it's across from the 60, so that would mean it would be 4 radical 3. All right, a review of the quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Since this is quadrant 1, this is 0 degrees. Up here is 90 degrees. The left is 180 degrees. Down at the bottom is 270 degrees. This side right here is always where we're going to be starting from. This will be our initial side. So if I have an angle, this is my initial side. And this would be my terminal side. And our initial side always starts at 0 degrees. Terminal is where we end. I know it's kind of a little bit morbid to think about, but terminal means it terminates. So somebody who has a terminal illness means their life is going to end, and that's where our angle ends because it terminates, it ends. Okay, next page. We have coterminal angles. And we define this as angles which have the same initial and terminal sides, but differ in the number of rotations around the origin. Okay, so if I label again, this is 90 degrees, or 0 degrees, 90, 180, and 270 degrees. If I draw an angle coming out from the origin into the fourth quadrant, if I start here at 0 degrees and I go counterclockwise and I stop there, this would be 300 degrees. If I start here and go clockwise, this would be a negative 60 degrees. So 300 degrees, which is counterclockwise. And then my negative 60 degrees, which is clockwise. They are coterminal angles. And they're coterminal angles because they start and stop in the same place. All right. So the directions say find the smallest possible positive coterminal angle. And then it says to draw. Drawing a picture helps us, so we get used to seeing what they look like. So let's draw a picture of 430 degrees, what that looks like. This is 0, this is 90, this is 180, this is 270. Once around is 360 degrees. So if I start here and I go all the way around once, that's 360 degrees. So in order to go 430 degrees, I have to figure out how much farther I need to go. So if I take 430 and subtract from it 360, I will get 70. So I have to go 70 more degrees, and 70 more degrees will leave me in quadrant 1, approximately there. So I'm going to continue on here from 0 degrees and go the extra 70 degrees. The smallest possible positive coterminal angle is the difference that I went. It's just 70 degrees. Starting from here and going to there, that's the smallest possible coterminal angle that I can have. So for 870 degrees, zero, 90, 180, 270. If I'm going to go 870 degrees, all the way around once is 360. So 870 minus 360 is 510. That means I can go another complete rotation. So subtract from that another 360, and I have 150. From there, 150 would put me into quadrant 2. And we kind of just guesstimate. So from here to here, that means my smallest possible positive coterminal angle is 150 degrees. I'm starting here and going here. That is the same as going 870 degrees. All right. I would like you to draw a smiley face on the bottom of this page, on the right-hand corner. All right, so now for C, we have a negative 400 degrees. So that means this time when I draw my picture, it's 0, this is 90, this is 180, and this is 270. Instead of going counterclockwise, I'm going to go clockwise because I'm going in the negative direction. So I'm not going to go 0 to 90, 180 to 270. I'm going to start at 0 and go towards 270. So a negative 400, well, that means I have to go around once backwards. So I need to figure out how much further I have to go. So 400 minus 360 is 40. So that means I have to go another 40 degrees till my angle ends, which means I'll be in quadrant 4. And that's a negative 40 degrees. But the directions told us to find a positive coterminal angle. So what I need to do is figure out the angle that starts here and goes in the positive direction and ends there. And in order to do that, I just need to take 360 and subtract 40 from it, and I will get 320 degrees. So this 320 degrees is my smallest possible positive coterminal angle. Last one. So 0, 90, 180, and 270. Since it's negative, I'm going to go this direction again. So 610 minus 360 is 250 degrees. Well, 250 degrees is going to put me into quadrant 2 because I'm going backwards. So this is a 180. And if I were to go all the way up to a 90, is that's 270. So I'm going to go approximately here. And now I need to figure out the smallest positive coterminal angle because this is a negative 250 degrees. So I need to figure out what that positive angle is. So I'm going to take 360 and subtract from it 250. So that's 110 degrees in the positive direction. All right, so some of this was a little bit of review. Some of this was brand new to you. But coterminal angles start and end in the same spot. They just have a different number of rotations around the origin.